Hi, good afternoon. I'm Haggai Scolnicov. I'm the Chief Visionary Officer of Iot. I'll tell you a little bit about what we're doing at Iot later. It's a great bunch of people, only slightly hindered by my presence. But what I'd really like to tell you about is where Internet of Things meets data science or data analytics. Now, I've been doing some of both for a long while. I guess I was doing data science before they called it data science, and Internet of Things before they called it Internet of Things. So both really interesting, and they get really interesting when they meet. So before I get into where they intersect, why should you care about the IoT? So actually, people have made that a bit easier for me earlier today talking about IoT here. But they kind of said you should be interested in it because, well, it generates a lot of big data, which is cool at the Big Data and Analytics conference. But, you know, did anyone use the Iot highway today to get here or over the past week? Okay, you're tired after lunch, but obviously you've all used the Iot highway over the past week, right? So you were on the Internet of Things when you used the Iot highway. How do I know? Because there's cameras on the Iot highway. You're a thing on that Internet of Things, even if you're not broadcasting information. You're the little green rectangle or the little purple oval or whatever scooting along the highway, and that information gets used sometimes automatically, sometimes manually, down to making various decisions about the world around us. Sometimes for our own good, to help in managing that highway, to tell us or to tell someone else where there's heavy traffic, light traffic, or perhaps a disturbance which someone needs to go out and deal with. These sensors are everywhere. I don't want to sound like a conspiracy theorist here, but these sensors are everywhere, right? They're only going to be in more places and in more parts of our life, whether it's in manufacturing and logistics, whether it's in our homes, in the utilities which serve us, and so on and so forth. And the point, I suppose, about the Internet of Things, right? There's even today you've heard several conflicting accounts, I suppose, as to what the Internet of Things is. The point, especially as it relates to analytics of things, is the things. It's not the Internet. I mean, yes, it's about things which have sensors in them, and it's about that data being communicated back between the things, or more importantly, to the cloud, to a central location. Does it happen over the internet? Does it happen with, older legacy systems inside the factory, inside whatever? Possibly that data going back and increasingly also going towards the devices, towards things, towards actuators which can move a robotic arm, lock your house, make a call, power up electricity somewhere. That data is, if you like, the data layer of the Internet of Things. It's the Internet parallel. But where is the web parallel? Or where are the various applications on top of the Internet of Things? So those are the really interesting bits. And that's where analytics comes in. The world of IoT, and I'll come back to this in a moment, the world of IoT has been working very hard on physical layer networking for demanding IoT situations. It's been working very hard on protocols, basically everything to get data from X to Y, right? But it's the smart applications with multi-sensor real-world systems which bring us real value, obviously, right? Same as IP communications are not in themselves what make the internet such a useful resource. We're not really one of those big business events, So I don't have all the nice Gartner charts here, but it kind of makes sense, right? And we'll come back to that scale in a bit as well. In a couple of years, we already have billions of sensors connected. We'll have tens of billions of sensors connected, and it all adds up to this huge industry-changing paradigm, also generating, analysts all vie with each other to come up with, is it trillions of dollars of value, or is it hundreds of billions of annual revenue, or whatever. So I wouldn't be here if the Internet of Things didn't require analytics, and it didn't desperately require analytics. Why do I say desperately? Because we know every industry needs analytics, right? It's this nice thing you can always tack on to an industry and say, I also do analytics for that industry. But that's not exactly the case here. So, if you will, this is kind of a simplified stack for an IoT application. It's a bit abstracted. If you have an IoT application, somewhere at the top is going to be a nice dashboard or user interface doing something cool and useful and domain specific. And it's kind of obvious that the application developer is going to have to solve that bit, right? It is in the application specific area, in the domain specific area. And the Internet of Things community has done a fantastic job. It's still doing it, right? Don't take this to mean it's a solved problem, but they've done a fantastic job of taking those bottom layers where you need sensors, and then you need networking, and you need device management, because you've got these 1,000 or 1 million unattended devices somewhere out in the world generating data, or failing to generate correct data. We've done a great job of making that kind of available, ready, packaged for the IoT application developer, right? You don't need to worry about that. Sure, you do need to worry about it, but you can kind of connect to a cloud system and you just point your standardized IoT devices somewhere and it almost works on its own. But where there is a big lack of tools of general purpose, universally applicable, or widely applicable tools, is that middle bit of the stack there. And the most important bit, I'll kind of gloss over visualization and data management for a moment, because I see them as going along together with data management, with data analytics. But where there's a big lack is around that data analytics or that data science area. And there's different reasons for that. One of the reasons is there's just not enough data scientists to go around. But the most often repeated reason is some variant of that. I'm sorry, it's your problem, it's domain specific, it's part of the application. You can't get something generic to help you, not to help you build. Of course you can get Python libraries if you know how to do the data science and you want your support vector machine or whatever. But if you want something packaged, I'm sorry, you can't get that packaged, because then it would be application specific. It's your problem, Mr. or Mrs. IoT application developer. And the important thing I want to mention about that before moving on is the order in that stack is important. If you're doing BI for a supermarket chain, right, first you have the supermarket chain, and they know how to sell biscuits and canned goods. And once they've already done that, you collect lots of data, and you can do business intelligence on that, and you improve, I don't know, profits or whatever by 10%, which is cool. But in an IoT application, and I'll go into this more in a moment, typically the product is the analytics, or at least it has to go through the analytics, because the data you get from the cameras on the Ayalon highway is not interesting to people to watch generally. What's interesting is counting the cars and telling you how busy the highway is, or more importantly for the guy in operations, is to just say, I'm going to pick out the ones for you where there's an anomaly at the moment, because the guy in operations isn't even going to watch the traffic numbers continuously. And the same goes basically for almost all the interesting cases where you collect real-world data. So I'll come back to solving that problem in a moment, but okay, so what else other than the ILON highway can you monitor or can you help with IoT analytics? And is it useful? Is it a big thing to do? I hope some of this is legible. It's terribly small, and the screen might not be large enough. Problems from industrial manufacturing, often referred to as Industry 4.0 or the industrial internet. Can I monitor machines with simple sensors like vibration and noise and electric current and tell before my production line fails, before the machines break? Problems from water and electric utilities. Can I determine consumption before it occurs? Can I tell if a leak has started in a neighborhood where all I have is total flow into that neighborhood, total flow being consumed? Traffic management, which I mentioned before. Smart home. If I drop a nanny cam at home, do I need to watch it to know if something is going wrong, or can I be told when something important is going on for me to watch? Or conversely, when I don't want to put a video camera and I still want to know whether my 90-year-old grandmom is okay at home without the intrusiveness of a camera. So for much simpler sensors around the home, can I tell how an elderly person is doing and feeling? So the problems are everywhere, and despite sounding very different, I'm going to show you that there's quite a bit of commonality to these IoT analytics problems. So wait, before I do all of that, rightly or wrongly, I'm smack bang in the middle of the big data track, and I haven't actually said big data explicitly until now. So you may be wondering if IoT is big data or not. As always, the answer is it kind of depends. Sometimes it's big data, sometimes it's small, sometimes it's very small data masquerading as big data, or the other way around. Some IoT data, without a doubt, is big data. IoT is a great way to generate big data because you have unattended devices just constantly spewing out bytes of information. Things which are per consumer, if you have millions of people with these wearables or smart home systems or whatever, and you're going to have billions with them, that's a 1 billion multiple. We're going to see lower and lower cost IoT devices. Therefore, we're going to see them on lower and lower cost things around the home. When your milk carton and your clothes come with a connected system on them, even if it's just something which says, yes, I am in your fridge, or no, I'm not in your fridge, we're going to have perhaps hundreds of nodes, things per consumer. We already have very high frequency IoT devices. Not incredibly high frequency. I think the 50 hertz example before was one of the higher ones I've heard from like non-laboratory settings. But even once a second, if you're going to save, your history for a couple of years back, because everybody needs to have a year's worth or a few years' worth of history to figure out repeating annual trends, cycles, that's going to be a lot. And of course, you have rich data. IoT, people often think of IoT on the very simple sensor side, sending over a number, but there's also video and to some degree audio, sending high bandwidth data. Multiply all of that together, you get some very big data examples. So there are some really interesting examples, and they're no less interesting on the analytics side, where you have perhaps not small data, but definitely medium data, where you don't need all the clever big data tools. In fact, the challenge there is, how do I find out what's going on despite having very sparse coverage of the world? Maybe I only see people at the convention center, not here where we just walk through blindly, but at a slightly larger one, we only see people where they have to badge in at a room, and in between we're just completely missing coverage of what they're doing. So it can be things like a utility network, which might be monitored per neighborhood. Previous company I was at, Takadu, we monitored water utility networks, and we just had the flow number going into a large residential neighborhood. You do monitor all of London's water network with a few thousand sensors sending data once every quarter hour, and it's one number that they send. So that's kind of the medium data side of things, and that can be just as challenging. So I keep saying IoT analytics. How is that different? Well, obviously it's not completely different, right? I mean, somewhere at the bottom of things there's going to be some machine learning basics, and someone is going to be correlating time series, etc. But when you try to package it up into more easily consumable units of data science, you find that the different data means you have, or different parameters of the data, means you have different parameters for your solutions. I've kind of grouped the differences into three big buckets there. Well, big data. I won't explain about big data, obviously, since we're in the big data track. I will just say perhaps the parameters there tend to be a bit special in some of these real-world systems where people are deploying new sensors, moving sensors, etc. all the time. It also tends to be messy data. Now, data is always messy, and you always have to clean data, but there are special ways in which unattended devices create messy data. They have a lot of noise. They have a variety of ways in which they fail, and you may not even know it. It's not a system which isn't sending data, it's sending data. Something is wrong with it. And you can't trust it, you need to know that. And it comes with all this real-world context and changes. And I think perhaps the most interesting thing which happens frequently just because of the constraints of sensing the real world is indirect data. And the thing about indirect data is that you don't actually have a sensor which tells you about traffic jams or about elderly people not feeling well or about machines going to fail. What you tend to have are things like microphones and cameras and vibration sensors and I don't know, you can measure electric current. And someone, the application developer typically, has to kind of piece together, oh, I'll use these indirect bits of information, and then I want to go through IoT analytics, appropriate IoT analytics, to get to what's actually happening in the world. And then I run into anomaly detection because I get this whole needle in a haystack situation, and I run into misleading external events, et cetera, et cetera. So, you know, some real-world data problems which you actually run into doing IoT analytics. You have thousands of cameras outside in your smart city. Guess what? Some of them have dirt on the lens today. You can't actually trust what you're seeing. You know, it's not a huge computer vision task, but if you don't know that something is obstructing your field of view or there's dirt on the lens, you're going to have a lot of false negatives. 5 minutes, thank you. Goodness. Those same cameras probably roughly cover some highway or some area of the city, but objects have this nasty habit of moving from sensor to sensor or camera to camera. You need to track them between them. I mentioned before, you can measure water flows, but you're actually only using that indirectly as a proxy to detect when there is a leak somewhere downstream of the flow you measured. How? Based on historically what you would expect to see flowing at this time, and now you're seeing something different. I want to recognize household activities, but the people in the house, for some weird reason, refuse to have video cameras watching them every second of the day. So I use sound. I say, oh, it sounds like someone is preparing dinner or is pacing about the house. Just the last examples, I mentioned the people at the convention center could be just as well. Real example we were involved in, you have cars driving around the city. They get their license plate automatically read at certain critical points throughout the city. But there's a handful of these points, and what you want to know is which of them are engaged in some suspicious or illegal activity. For example, are there unlicensed taxis, or is it doing something else which relates to how people are using this car, right? That was my example from the opposite end of big data. The problem here, you might get a lot of readings, but you're actually getting a lot less than you would like. You definitely don't have tracks, full GPS tracks as they drive through the city. So what am I doing about, or what are we doing about it at Iota? Briefly, we're creating a platform for IoT analytics. So application developers, typical application developers, don't want to be told, I think you can use OpenCV to solve this computer vision problem. And they don't want to be told, I think if you took a classifier and you prepared your data properly, you could do activity recognition. And they usually don't want to be told, we think you could do this with a MapReduce framework of some sort. In the Iota model, application developer writes their code, for example, to monitor a shopping mall, looks through a library of IoT-aware analytics components, and says, for example, I'm going to use this one component which just marks where there are people in a video stream, and it does it pretty well. And I'm just going to use this other component which does anomaly detection on time series of vectors of floating point numbers. And sure, they need to do some glue work before, in between, and after that in order to get something working, which will tell them, are there too many or too few people in some part of the shopping mall? But we take that heavy lifting off their hands. So on top of that, it is a two-sided platform. It's open for component developers. I think this is going to be a key thing for IoT analytics. I don't mean just, well, I mean, I hope it will be through Iota, but in the world of IoT analytics in general, this is going to be a key thing. Because you need a large library, right? That guy building the shopping mall application happened to find the two right components. So that means there's hundreds of relevant components in there for different data types, et cetera, et cetera, et cetera. So it's a two-sided platform. It's basically an environment which makes it very easy for a data scientist to create, quote unquote, just the algorithmic code, leverage these powerful platform services, including things you've heard about today, e.g. Storm and whatever, and create in the cloud, run through Iota these analytics as a service, which may be consumed by application developers. Some of those get built by Iota. That's what we're doing now. Some of those will very soon get built by third-party component developers who, of course, share in the revenue. So it creates kind of a marketplace for analytics as a service. I don't think we'll have time to talk about what that can contain, that toolbox. It obviously needs to contain multiple data types and multiple packaged machine learning things like anomaly detection, activity recognition, and various headline analytics you might use. I'll just say the point of all of that is to create an application such as this one, where you could, again, monitor, sorry for, again, taking a video example, just makes it a bit more visible, where the glue bits, which you need to construct as an application developer, are focused on your system, your data, your domain, and are not focused on things like, but how do I know what kind of noise I'm listening to? How do I correlate large sets? How do I search for anomalies? That's it. Thank you very much for your attention, and I will be around for any questions.